Assalamu alaikum dear students. Exercise number 1.5 and question number 1 we have to solve today. The topic is of our chapter matrices and determinant. We have introduced with the its first type matrices and now it's determinant. In the question number 1 and 2 you have find and understand the method how we'll find the determinant of a given matrix, and further in question number 2 which of the matrices are singular and which is of the following matrices are not singular. We have studied their definition and also find that singular and non-singular matrix. But in question number 3 of exercise number 1.5 you will introduce with a new term, a new method, or you may say another formula, that is the multiplicative inverse. Multiplicative inverse of a matrix. We have to find the multiplicative inverse of the matrix. In general real numbers, if we'll discuss that multiplicative inverse of a number, I have explained you that in real numbers, or you may say real numbers, complex number, or any rational or irrational number, multiplicative inverse of a number 5 is such a number that it will give answer 1. So what will multiply 1 over 5 will multiply with 5, so that the answer would be 1. So multiplicative in digits in real numbers of a number is the reciprocal of that number, so that answer is 1. Similarly 3, its multiplicative inverse would be 1 by 3. 7, its multiplicative inverse would be 1 by 7 cancel, it is 1. 7, so it means in real number the multiplicative inverse of a number is the reciprocal of that other number. But we are discussing about matrices, how we'll find the multiplicative inverse in matrices. So students, in matrices, if we are given with the matrix A and we have to find its multiplicative inverse, it will denoted by A inverse. Then it will always give an identity matrix. In matrix, the multiplicative inverse of a number of a matrix A, the multiplicative inverse of a matrix A, when multiply with the matrix, it will result identity matrix. It means we have to find A inverse. How we'll find A inverse? Multiplicative inverse of a number is equal, it is denoted by A inverse also. Multiplicative inverse of matrix A is obtained by taking adjoint of A and dividing by its determinant. The formula of multiplicative inverse, if matrix A is given, then its multiplicative inverse will be denoted by A inverse, that is equal to adjoint of A over determinant of A. If we are given with the matrix B, then multiplicative inverse of B is equal to adjoint of B over determinant of B. And what is adjoint of B and determinant of B? I have explained you in my last lesson how we determinant can be find. For example, we have to find the multiplicative inverse. For this I introduce a matrix B here. Just an example: 1, 3, 2 and 7. Then two things I need: first the adjoint of B, and secondly is the determinant of B. So first I will find its determinant. 1, 3, 2, 7. As you know, how will find the determinant? 1 into 7 minus 2 into 3. 7 1s are 7, 2 3 times 6, 7 minus 6 equal to 1. If the determinant of matrix is non-zero, so B inverse exists. Because determinant is not equal to 0, it is non-singular. But if it is singular, the answer would be 0. If the matrix have a determinant 0, then its multiplicative inverse not exist, because if we put the values here, we will find adjoint of B, and if the determinant of equal to B that is equal to 0, then the whole expression would become undefined. Therefore, to find multiplicative inverse, the matrix B should be non-singular. Okay, if the matrix is single, then its multiplication not inverse not exist. We will simply write that its multiplication inverse not exist. So students, note down that formula, that multiplicative inverse equal adjoint of that matrix divided by determinant of that matrix. So here I have find the determinant of B, and how will find the adjoint of B? You know, adjoint of B, while finding adjoint what we will do, we will change the position of these diagonal entries. 1 7 will become 7 1 and changes the sign of non-diagonal entries. 3 would become -3 and 2 would become -2. This is how we find adjoint. Now multiplicate inverse. B inverse is equal to, put the value here, adjoint of B equal 7 -3 -2 and 1 divided by 1, as 1 is the denominator of every number. So B inverse equal 7 -3 and -2 1. So students, this is the multiplicative inverse of that matrix B. Note that B multiplied by B inverse is always I. Now we'll check that if we find the multiplicative inverse, should the answer of matrix B and its inverse is always identity matrix. Let's check it out. Putting the value of B is 1372 and B inverse we have just find 7 -3 -2 and 1. It should be equal to I. Let's see. Multiply first row with first column. 1 multiplied by 7, 3 multiplied by -2. Now first row with second column. 1 multiplied by -3 and 3 multiplied by 1. Now second row first column. 7 multiplied by 7. Second row second column. 7 multiplied by 7 minus 2 into -2. Sorry, we are doing a mistake here. It is 2 7. 2 7 time 14 and 2 2 here will be then 7. It was 3 and -2. Now we will change the sign. 3 -2, it becomes 7 1. After changing, let's see it again. B equal 1 3 2 7. Then its joint will be 7 1 -3 and 2. Now we'll multiply B matrix, that is 1 3 2 7, with the inverse matrix 7 -3 -2 and 1. Now see this. First row first column. 1 into 7 7, 3 into -2 6. 1 into first row second column. 1 into -3 and 3 into 1 3. Now second row first column. 2 into 7 14 and 2 into 2 -2. Now second row with second column. 2 into 3 plus 2 into 1. 2 into -3 it was, that is equal to I. 1 into 7 7, 3 2s are -6, 3 1s are -3 plus 3 into 1 3. 2 into 7 14 and 2 into -2 is coming wrong here. Why it is wrong? Because 1 3 2 here is 7. We are doing some mistake in the value. It is 2. 7 into 2 -14. 2 into 3 2 into -3 and 7 into 1. It was 7. 7 into 1. So -6 plus 7. Let's see. 1 0 0 1. Clearly this is equal to I, identity matrix. So multiplicative inverse of a matrix, multiplying a matrix with its inverse will always give identity matrix. So students, in question number 3 our working will be till here to find the multiplicative inverse. We not need to verify that the multiplicative inverse of a matrix equal to identity. This is only to give you a concept that multiplicative inverse of a matrix and the matrix itself is always identity matrix. This is I have done this to explain you that multiplicative inverse of a matrix with the original matrix would always be equal to identity matrix. Now we will solve question number 3. Okay student, question number 3 now. Question 3 has 4 parts. Find the multiplicative inverse if exists in each of the following. If exist mean if the determinant 0, we will write its determinant not exist. Is multiplicative inverse not exist. Question number 3. Find multiplicative inverse if exist, and the first matrix is -1 3 2 0. -1 3 2 0. Multiplicative inverse is equal A inverse is equal adjoint of A over determinant of A. We'll say this as equation number 1. Now we'll matrix A is given, finding its determinant. You know how to find determinant. Write 2 lines on the matrix which represent the matrix and also on the entries of the matrix. -1 into 0, -3 into 2, -1 into 0, 0 multiply with every number 0, 3 into 2 -6. So determinant of A is equal to -6, not equal to 0. So A inverse exists. It means its multiplicative inverse exists. But if it is 0, then we will say that its multiplication inverse not exist. Now adjoint of A is equal. In adjoint, what we'll do, we will change the position of diagonal entries. Here we'll have -1 0, it turn as 0 -1, and change the sign of the non-diagonal entries. 3 2 will become -3 -2. This is the adjoint of A. Now putting the value in equation 1, putting values in equation 1. Putting the value in equation number 1, equation number 1 is this: A inverse is equal, what is the value of adjoint of A? That is 0 -3 -2 and -1, and determinant of A is equal -6. Now students, here it is interesting, when you divide any fraction, any number in which there exists a reciprocal, need to do 2 steps for better understanding. 0 -3 -2 -1 divided by -6. In the fraction it means divided by -6. Now when this division sign changes into multiplication, -6 will become reciprocal. It would become 1 over -1. 1 over -1 you may write, -1 over 6 you may write, or you write minus into 1 by 6. It is same. Now we'll multiply both of them. -1 by 6 into 0 -3 -2 -1. Multiply them. 0 into -1 by 6, -1 by 6 into -3, -1 by 6 into -2, -1 by 6 into -1. 0 multiplying with any number will result 0. 3 1 times 3, 3 2 times 6, minus minus plus, it is 1 by 2. Minus minus plus, 2 1 times 2, 2 3 times 6, minus minus plus, it is 1 over 3. Minus minus plus, minus minus plus, 1 over 6 into 1 is 1 by 6. So this is the multiplicative inverse of the matrix A. A inverse equals 0, 1 by 2, 1 by 3 and 1 by 6. See the students, again the formula for multiplicative inverse is A inverse equal to adjoint of A over determinant of A. First you will find the determinant of A. How we will find the determinant of A? We will simply put brackets around the matrix A and also its entries. Determinant A finding, how we will find the determinant? -1 multiplied by 0, -3 multiplied by -2. -1 multiplied by 0 equals 0, 3 multiplied by 2 is -6, 0 minus 6 equal -6. As determinant is non-zero, so its multiplicative inverse will exist. So its multiplication inverse will exist. Now we'll put the values. Before this we will find the adjoint, because to find multiplicative inverse we require 2 things: adjoint of A and determinant of A. Adjoint of A can be found by changing the position of the diagonal entries. -1 0 will become 0 minus 1, and changing the sign of non-diagonal entries. 3 2 will become -3 and -2. Putting the value in equation number 1, adjoint of A 0 -3 -2 1 divided by determinant of A, and determinant of A equal -6. as this whole matrix is divisible by -6, and you know in the previous classes you have better understanding with that concept that when division changes into multiplication, it make the reciprocal of the number ahead of it. uh, minus this division become multiplication, and this -6 will become 1 over -6. 1 over -6 is multiplying with whole matrix, and multiplying a number with whole matrix, it mean multiplying the digit with all of its entries. -1/6 into 0, -1/6 into -3, -1/6 into -2, and -1/6 into -1. 0 multiplying with any number will result 0. 3 ones are 3, 3 2 times 6, minus minus plus, it is 1 by 2. 2 ones are 2, 2 threes are 6, minus minus plus, it is 1 by 3. Minus minus cancel, 1 over 6 into -1 is 1 over 6. So this is the multiplicative inverse of the matrix A. Similarly students, the part B, C and D are given. I will solve part number 4 now because it contains a fraction. You will have to do its part second and third. I am going to solve its part 4 now. In part 4 we have fraction D, matrix D, having entries 1 by 2, 3 by 4 and 1 and 2. Now multiplicative inverse, multiplicative inverse is equal D inverse equal adjoint of D divided by determinant of D. We will find first determinant and then adjoint of D and put the value in that equation number 1. Simply we'll find the determinant. So first determinant of D is equal 1 by 2, 3 by 4, 1, 2, 1 over 2 into 2, as you know you multiply these two, minus 3 over 4 into 1. 2 cancel with 2, we have 1, minus 3 over 4 into 1 is 3 by 4. Here students will take the LCM. Its denominator is 1, so 1 and 4 LCM is 4. 1 divided by 4 is 4, 4 into 1 is 4, 4 divided by 4 is 1, 1 into 3 is 3. So the answer is 4 minus 3 is 1 by 4. Determinant of D is equal to 1 over 4, not equal to 0. So we'll write determinant D inverse, that multiplicative inverse exists. Students, don't be confused here. 1 minus 3 over 4, we will find the LCM here, and it is a long explanation of the LCM. I hope all of you have done in the previous classes. So if you not understand that step, all of you will say me, sir यहाँ से समझ नहीं आया, and so on. Note this, 1 minus 3 over 4. Maybe you have done the LCM work like this. We want to make the denominator same. For this I will multiply it 4 by 4 minus 3 by 4. Now I have 4 by 4 minus 3 by 4. 4 LCM is 4, 4 minus 3 is, so see this, they are same. It's up to you which method you attempt. I don't know what method of LCM or solving fraction you people have done in the previous classes. Here I have done both of method for you. First, that is of finding LCM. 1 multiplied by 4, 4. 4 divided by 1 is 4, 4 into 1, 4. 4 divided by 4, answer 1. 1 multiplied by 3 is 3. So 4 minus 3 is 1 by 4. Another method which may have you done in class 8 and 7, 1 minus 3 by 4 is to make the denominator same. To make the denominator same, I need 4 in the denominator, so I will multiply this fraction with 4 by 4. When my denominator same, I will write denominator only once and subtract or whatever the operation given in the numerator. 4 minus 3 is 1 by 4. As multiplicative inverse, the determinant of D is 1 by 4, that is non-zero, so its multiplicative inverse will exist. I have find the determinant of D and I now need adjoint of D. Adjoint of D is equal to, now what we'll do in adjoint, we will change the diagonal of the matrix. Diagonal of matrix, position of the diagonal matrix will be changed. 2 and 1 by 2 and sign of non-diagonal entries, minus 3 over 4 and minus 1. Now put the values in equation 1, or you may write 1 becomes D inverse is equal to adjoint of D. What is the value of adjoint of D? 2 minus 3 over 4 minus 1 and 1 by 2. And what is the value of determinant of D? It is 1 by 4. Now again 2 minus 3 by 4 minus 1 1 by 2 divided by 1 over 4, and when this division sign changes into multiplication, it will become multiply by 4. So now 4 will multiply with all the entries inside it. Four multiply by 2, 4 multiply by minus 3 over 4, 4 multiply by minus 1, 4 multiply by 1 by 2. 4 cancel with 4. It is 8 minus 4. 4 cancel with 4 minus 3. It is 2. So this is the multiplicative inverse of the matrix D. Students, I am going to explain you it again. Multiplicative inverse of a matrix D, we will have to find 1 over 2, 3 by 4, 1 and 1 by 2, 1 and 2, adjoint of D, determinant of D. You find the determinant, it is non-zero. Find the adjoint, divide both of them and get the answer. Thank you so much. Students, you need to do complete part 2nd and 4th in the homework. Part 3 would be 2nd and 3rd in the homework. In fact, part 2nd and 3rd are so easy. In the 3rd part, determinant will occur 0, so its multiplicative inverse will not be possible. So only you need to do is the part 2nd in the homework, part 2nd and 3rd. I will write it for you. So students, homework for you. Homework is find multiplicative inverse of question number 2. B matrix is given 1 2 minus 3 minus 3 minus 5, and 3rd part minus 2 6 3 minus 9. It is C matrix. Students, C minus minus plus 2 9s are 83, 6 are 18. Its determinant would be 0, and you will simply write it so multiplicative inverse of C is not exist. Only you need to solve part B in the homework. Thank you so much. We will start question number 4 in our next lesson. Thank you so much. Take care. Allah Hafiz.